Hi, welcome to myprojectbazaar.com. Now we are going to see the title, a utility maximization framework for fair and efficient multicasting in multi-carrier wireless cellular networks. The explosive growth of wireless broadband multimedia services has placed an unprecedented demand on the already scarce wireless spectrum bandwidth. By multicast, we mean the base station transmit the same data to multiple mobile users at a single transmission. The traditional multicast scheme puts all users that record the same program in one multicast group. The BS, that is a base station, multicast to all users in a group on the subcarriers allocated to this multicast traffic. To ensure the signal reception quality of each user, the data rate is adapted to the worst channel condition among all users within a multicast group. So it may lead to a capacity limitation problem. So in order to eliminate those problems, we are designed a simple yet efficient scheme to enhance the capacity of OFDM based wireless multicast cellular systems without the need to involve successive decoding or dynamic resource allocation. And then in particular, we are interested in finding the optimal way of partition users into multicast groups so that the spectrum efficiency is maximized. Initially, grouping more users together leads to a lower data rate at each subcarrier simply because the data rate is determined by the worst users channel, the gain of which decreases with the number of users. So, we are aims to strike the optimal balance for this trade-off. It is worth noting that the traditional multicast scheme, which put all the users that require the same content in one multicast group, is at one end of this trade-off and hence could be far from the optimal. Now we are going to see the DFD diagram. First, enter the number of users and split the users into different groups and allocate subcarriers and bandwidth to each user in separate groups. Compute data rate for each group and as well as the each node, and compute equal path losses and different path losses. Equal path losses can be computed among the one group, and compute different path losses, that is different path losses can be computed among the different groups, and apply the utility function in order to solve the losses in order to achieve the optimal solution for the data transfer. Now we are going to see the project. The front end is NetBeans and the back end is MySQL. And the front end, inside the utility package, choose first.java and click run file. Enable draw nodes. So here 18 nodes are created here and each one belongs to separate group. Then click next. Calculate distance between each nodes. The values are shown here from base station to other nodes. Then click next. Then click cluster. So based upon the location, the clusters are forming, and in group 1 7 nodes are there, and in group 2 5 nodes are there, and in group 3 6 nodes are there. Then click average power. So for each user, the average power received by all user is 5.0. Then click power for each user. Now we calculate the power for each user. So one has the power as 1.640, and click SNR. So click SNR. So signal to noise ratio for each node is calculated, and click data rate. So data rate values are calculated and it should be inserted into the database. So now we are going to see the equal path loss. So equal path loss. So the equal path loss is optimized by using the two methods. One is the optimal multicast scheme, so another one is the AAT. So in order to solve that problem, we are calculating the values by using the optimal multicast scheme. So we need to apply these values to the nodes and click AAT. So asymptotic throughput formation is achieved. Those values are calculated and equal path loss case is optimized. And now we are moving to the different path loss. So in order to solve the different path loss, we need to use three methods. One is throughput, another one is the proportional, and third one is the max min fairness. So based upon three methods, we are calculating the values. Through this value only we are optimizing the different path laws. So these are all the values occurs, and in order, if we apply those values to the nodes, means our different path laws case can be optimized. Thank you.